correlation may be defined as a statistical study involving relationship between two or more variables. For example, in life sciences, we can measure the correlation between obesity and blood pressure, obesity and diabetes, or even the nutrition supplied to a plant and the yield of the plant, etc. If the two variables that we are measuring, they move in the same direction, that is, when one increases, the other also increases, or when one decreases, the other also decreases, then we refer to it as positive or direct correlation. Whereas, if the two variables that we are measuring move in opposite directions, that means when one increases, the other decreases, then it is referred to as a negative correlation or inverse correlation. If we make a plot of the two variables on the two axes of a graph and we obtain a straight line, then it is referred to as linear correlation, or if not, it is a non-linear correlation. Correlation can be studied mainly by measuring the degree of relationship between the two variables, or the strength of the relationship between two variables, and the most important coefficient that is normally measured is the Karl Pearson's correlation coefficient for linear correlation. The value can vary between +1 and -1. Plus or minus indicates whether it is positive or negative, and the value indicates the magnitude of the relationship. A perfect positive correlation, we get a correlation coefficient of +1, and for a perfect negative correlation, we will get a value of -1. Plus or minus 0.9 indicates a very high degree of correlation. 0.75 to 9, either a positive or negative, indicates a fairly high degree of correlation, and 5 to 0.75, either plus or minus, indicates a moderate degree of correlation. Less than that, it is low or very low degree of correlation. When we are doing a correlation analysis in statistics, we calculate the correlation coefficient. Though from the value of the correlation coefficient we know the strength of the relationship, we can also check about the significance of the relationship between the two variables using a significance test. And in analytical research, we can also establish the cause-effect relationship. We can try to analyze the cause-effect relationship. We will see about the calculation of Karl Pearson's correlation coefficient. So we have two series of data, X and Y, and we have to calculate the correlation coefficient. This is the formula denoted by R, correlation coefficient for a sample. It is equal to sigma dx dy by root of sigma dx square into dy square, where dx is x minus x bar and dy is y minus y bar. For simplicity's sake, it is given as dx dy. Now, if we have to find out what is dx, that means we should know what is the mean for the x series, and we should know the mean for the y series to find out dy. So we know that x bar is equal to sigma x by n. So if you total all these data, you will get 120, and the number of items is 8. So x bar is equal to sigma x by n, and sigma x is 120, n is the sample size, it is 8. So we get the mean as 15 for the series of data in x. For y, the total is 72, and the number of items again is 8. So 72 by 8, the mean for the y series is 9. So now we have to start subtracting each and every variable from the mean. So 12 minus 15 will be minus 3. 18 minus 15 will be 3, 16 minus 15 is 1, 15 minus 15 is 0, 12 minus 15 is minus 3, 10 minus 15 is minus 5, 20 minus 15 is 5, and 17 minus 15 is 2. So this is about dx. So we'll move on to dx square. We need dx square, dy square, dx dy. So let's complete dx square. So this is going to be 9. Again you will have 9. This is 1. This is 0. This is again 9. This is going to be 25. This is going to be 5. and this is going to be 25, and this is going to be 4. So this is about dx square. Now we'll move on to sum of this is 82. Yes, sum of this is 82. So we need sigma dx square, so we have done that. For dy, remember we have to subtract y from y bar. So don't forget, do that carefully. So 6 minus 9 will be minus 3. 10 minus 9 will be 1. 9 minus 9 will be 0. 8 minus 9 will be minus 1. Again 9 minus 9 will be 0. Then again 8 minus 9 will be minus 1. Then 12 minus 9 will be 3. And 10 minus 9 will be 1. Next we have to square this. So it's going to be 9. It's going to be 1. Then 0. Then 1. Then again 0. Then 1. 9, 1, 22. The total is going to be 22. So we have got sigma dx square, we have got sigma dy square. So now we need sigma dx dy. So minus 3 into minus 3 is going to be 9. 3 into 1 is going to be 3. Then 1 into 0 is 0. Then 0 into minus 1 is again 0. Then minus 3 into 0 is 0. Minus 5 into minus 1 is 5. 5 into 3 is 15. And 2 into 1 is 2. So this is going to be 34. 12, 17, 32, 34. So now we have got all the terms required. R will be equal to sigma dx dy, which is 34, by root of sigma dx square is 82, sigma dy square is 22. So root of 82 into 22. So multiply, find out the square root, divide by 34, and you will get the correlation coefficient as plus 0.80. Karl Pearson's correlation coefficient can also be calculated using Excel. So for that we have to go to insert function option, and under statistical you have to move on to correlation. So you have CORREL correlation, so click on it and OK. So now you have to choose the two arrays. So I have actually put my X data and Y data in rows. So I have to choose X, which is the first array of data. This is one variable. And in array 2, I have to feed in my next set of data. And we get the result. The result is 0.80, the same thing which we got manually also. So this is one way of doing it. Another way of doing it is you can go to data analysis, and in data analysis also you have correlation option. Click on OK, and here you have to indicate clearly whether you have put your data in rows or columns, in what way they have been grouped. Each set of data is in a row or is in a column, because we are comparing two sets of variables. So here in this particular case, X and Y for me, I have put it in rows. So I have checked the rows, and input range, now I can choose the full range because I have mentioned that it is grouped in rows. And I can get my result in a new worksheet. So I am clicking on OK. So this is the correlation coefficient. So it indicates the correlation for row 1 with row 1, row 2 with row 2, and the correlation between row 1 and row 2 is 0.80. Same thing which we got manually.